Welcome to the final section of Chapter 3. This is Chapter 3, Part 3. There will be a quiz after we finish this section. There will not be a Chapter 3 test. We will be testing Chapter 3 and Chapter 4 together. So Chapter 3, this is our last section before we jump into Chapter 4, but there won't be a test, there will be a quiz. So in this section, we are going to learn about what a matrix is and how to write it, and then how to use them in order to solve systems of equations on our calculator. And that way, we can use matrices in order to solve systems of equations with 3 variables. So let's start with how do we go from a system of equations to a matrix? And the key here is that we are going to make a column for our x's, a column for our y's, and a column for our values that don't have a variable, which are called our constants. So if you look at the diagram here, our blue column is x's, our red column is y's, and our green column is the constants. And we're only going to write in our coefficients here. So if I look at my first equation, the first equation here becomes the first row of my matrix. And in that row, we're going to write 1 for our coefficient of x, 3 for our coefficient of y, and then 7 for our constant. This vertical bar is to replace the equal sign. It separates our coefficients from the constants. We're then going to take our second equation, and that will give us the second row. So the second equation goes with the second row. So we have 3 for our x, we have 1 for our y, and -8 for our constant. Okay, so we can take any set or system of equations and turn it into a matrix. Now it's important that these aren't just random equations. These are the equations that make up a system, so they're related, and what we're looking for is then what makes both of those true. And we're going to learn how to use our calculator to use this matrix in order to solve the system of equations. Okay, so let's look at an example. The first thing that we need to be able to do is convert from a system of equations into a matrix. So we have 2 systems of equations here, and we're going to turn them into matrices. We're going to start out with a 2-variable system. We have x and y as our variables. So I'm going to go ahead and color code this, and we'll use the same colors as on the last slide, but you don't always have to use the same colors. So I'm going to start out with blue for my x's, I'll use red for my y's, and I'll use green for my constants. So a matrix, I'm only taking the coefficients. So I'll take 2 and 1 from my first and second equation. The variables are already lined up, so I don't have to worry about rearranging this. 1 and -6 for my coefficients of y, and then my constants are 9 and -1. And then in order to denote that this is a matrix, we're going to put kind of this square bracket around the outsides. And then optionally, we can put this bar down the middle, okay, where the equal signs was. Now, the bar, the vertical bar that replaces the equal signs is completely optional, and most calculators do not have that feature. Okay, so this is exactly the same as a matrix of 2, 1, 9. We read it across just like we were reading a book. 1, -6, -1. Okay, so that will be our first matrix. In part B, it gets a little bit more complicated because notice there are 3 variables here. We have x, y, and z. And not every equation has all 3 variables. So the first thing that I'm going to do is I'm going to set up a column for x, a column for y, a column for z, and a column for equals. Now we need to rewrite this system of equations so that we have our x's, our y's, and our z's all lined up. So my first equation is fine. I have x minus 3y plus z equals 6. My second equation is okay, except it's missing a y. So what I'm going to do is I'll say x, if I have no y, that's the same as 0y. Remember, we did the same thing when we were writing the equation of a line. If there was no x and there was no slope, we would put 0. So this is, I'm just going to put a placeholder here for y plus 0y plus 3z equals 12. And then our last equation here, now x is on the wrong side of that equal sign, so I'm going to add it over so that I get 5x plus 1y, there's no z, so that's plus 0z equals 1. And then we'll do the same thing where I take all of my x's that are now lined up, that's 1, 1, 5. I'll take my y's that are all lined up now, and including that negative, so negative 3, 0, 1, I'm going to use blue for z. Whoop, I used blue for x. Let me use, what color haven't I used? Yellow. So I'll use yellow for z. So that's 1, 3, 0. And finally, I have green for my constant, and that is 6, 12, 1. To denote that this is a matrix, I'm going to put the bar around, whoops, not including the x, that was just to denote. So those x, y, z at the top, those are not part of my matrix, that's just to help me organize. So my matrix is 1, negative 3, 1, 6, 1, 0, 3, 12, and 5, 1, 0, 1. Okay. Now, in order to tell the calculator that we want a matrix, notice how these are different sizes. So in order to tell the calculator what size matrix we want, we're always going to start with the number of equations by that number plus 1. So in part A, we have 2 equations. That's 2 by 2 plus 1 is 3. So we call that a 2 by 3 matrix. That's 2 rows and 3 columns. For part B, we have 3 equations. So that's going to be 3 by 3 plus 1 is 4. That denotes 3 rows or 3 equations and 4 columns. We're always going to have one more column than the number of rows because of that constant or equals column. Okay, and remember that bar that goes right in front of where the equal signs used to be is optional. Okay, let's take a look at our next example here. We're going to be working in 3 dimensions. So we looked at what does it mean for equations to be in a system. Equations with 2 variables are lines that cross each other. Equations with 3 variables are planes that cross each other. So now what we're looking at is we have 3, essentially think about 3 sheets of paper. And how can I arrange those sheets of paper so that they intersect each other? Okay, now it's a little bit tricky because these sheets of paper can kind of, they're like ghosts. They can kind of slide through each other. So not exactly like having paper, but a plane is a flat surface, right? So when we're looking at our options for systems of 3 variables, we have a lot more. We have 3 ways now to get no solution. We can have some planes intersecting each other, right? In this example, each of 2 planes intersect each other, but they don't all 3 intersect each other ever. So in order to be a solution, remember all 3 have to be true. If I've got 3 variables, I have 3 conditions that all have to be true. And so there are more ways for that not to happen. However, there could be a way that all 3 planes do cross each other, and it could be a point. Or now we can also have the 3 planes crossing each other and we would get a line. Okay, so there are a lot of ways to get no solution. there are a couple of ways to get a solution. So remember, these would be inconsistent, and these two would be consistent. Okay, now the other option is we can have the same plane 3 times, and that would also give us an infinite number of solutions, and that would look like just one plane. So if I had, imagine a stack of papers, I have a piece of paper on top of itself, that would be another option to get an infinite number of solutions to our intersecting planes. Okay, so just like before, there's a way to get no solution, there's a way to get a solution, and then there's a way to get infinitely many solutions. So let's look at an example in 3 variables and look at our steps. So we're going to actually solve this. We looked at how to turn it into a matrix, and now we want to solve it from within that matrix. So our first step is going to be to take our system of equations here and turn it into a matrix. So notice I already have my A's are lined up, my B's are lined up, my C's are lined up, and my constants are all on the other side of the equal sign. So let's go ahead and make a matrix here, taking only the coefficients, and it doesn't matter that it's A, B, and C instead of X, Y, and Z. The variables that we use don't matter. What matters is that all of the same variable are lined up. So if I put C's before A's, that's absolutely okay. Okay, that's just going to change the way that we write our answer. So if we look at this, our first column, our coefficients are 2, -4, and -2. Our second column going down, we have 3, 9, and there's nothing there, so that's a 0. Our third column here, we have -1, 2, and 2. And then we have our equal signs, and our constants are 1, 8, and 3. So there is our first matrix. Okay, now what we want to do is type this into the calculator. Okay, so let's take a look at typing this into the calculator for a second. I'm going to switch screens here to the calculator. And in order to type this into the calculator, what we have to do is go into the matrix menu. So kind of towards the left middle of your calculator, there should be an X to the -1 button. And above that, it should say matrix. And so we're going to go Y equals, whoops, sorry, let me clear some of these things out here. And we're going to make sure that plot 1 that we've been using in the last chapter, we're going to go ahead and turn that off. So press the up arrow and then hit enter. And let's make sure that plot 1 is not highlighted anymore. The reason we're going to do that is because since we're not working with stat plots anymore, we're not working with scatter plots, I don't want that to cause an error in the calculator. Okay, so now that plot 1 is off, let's go ahead and focus on our matrices. So we just have to do that one time. We're not going to have to do that every time. We're essentially setting up the calculator. Now that the calculator is set up, let's go ahead and put in our matrix information. So you're going to go second, matrix. And then this is where we could use our matrices. These are the functions that we can use with our matrices, and we're going to look at that in just a minute. And edit is where we can change the matrix. So that's okay if you don't have any numbers here, that just means you don't have any matrices that have been used. That's absolutely fine. Whatever your calculator says, we're going to go ahead and just edit matrix A. So we're just going to hit enter. It doesn't matter if there are numbers in here or if it's absolutely blank, that is fine. Now remember before when we were looking at our matrix, we said we want the number of equations and then one more than that. So we have 3 equations, and then I'm going to press the right arrow and say 3 plus 1 is 4. Okay, and then I'm going to hit enter, and that will let me start entering numbers into the matrix. Now, if you already have numbers there, we're just going to type right over them and they'll be replaced. Okay, if you don't have numbers, then it just filled in a bunch of zeros, and that's also okay. So if we look at the matrix that we just wrote down in our notes, the first row and the first column, so the first number, if I was reading it like a book, is 2. And then after every number, I'm going to hit enter. Now this is gonna fill in across and then down. So the next number we're gonna type in is 3, enter. And then we have a -1, not a -1, but a -1. So we're gonna use that negative sign right next to enter, -1. Notice it types it down at the bottom. It doesn't put it into the matrix until I hit enter. That's why we have to hit enter every time. And then the last one in that row is 1, enter. And then we're going to fill in our second row. So that's -4, not -4, but -4, enter, 9, enter, 2, enter, 8, enter. That's our second equation. And then our third and last row, we're going to do -2, enter, 0, enter, 2, enter, 3. Okay, and then hit enter one more time so that your whole matrix is entered. Okay, now at this point, the calculator knows our matrix, just like when we were doing scatter plots, we put in the list, but now we want to calculate with it. So to exit this menu, we're going to do second, quit. This is like the exit button. So shift or second, quit is the mode button right next to it, and that should take you back to your home page. Okay, so now what we want to do is we actually want to calculate with this matrix. So we're going to go into the matrix menu again. That's second matrix. But instead of editing it, now this matrix A is the matrix that we want to use. So we're going to go over to math, and we're going to go all the way down until we find our ref. So go all the way down to, it should be letter B, R ref. What that refers to is reduced row echelon form. Essentially, that means the matrix that's going to give me the answer. So then we're going to hit enter, and then we have to tell it which matrix to use. So back into that matrix menu, second matrix. We typed our matrix into A. Everybody typed it into A, so everyone's going to hit enter to use matrix A. Close your parentheses, and then hit enter. Okay, now what it gave me is it gave me decimals, but that decimal keeps going and keeps going. So let's turn this into a fraction. So turning a matrix into a fraction is exactly the same as turning a decimal into a fraction when we're doing calculations. We're going to go into the math menu and turn it into a fraction. Enter, enter. And so we've turned our matrix into the solution matrix, but now we have fractions. Okay, so if we're looking at this, what does this matrix mean? Well, just like before, our rows each have a meaning of a variable. So this matrix came from A, B, C equals, right? So we can take this reduced row echelon form matrix and turn it back into equations. So I have 1A plus 0 equals 1/2. I have 0 plus 1B equals 2/3. And then I have 1C equals to 2. So notice how these are all zeros, and we just have ones that go down on a diagonal. That is what makes it reduced row echelon form, that everything is zeros except for a diagonal of ones. Okay, and notice here we have our answer. A equals 1/2, B equals 2/3, and C equals 2. If we wanted to write this as an ordered triple, so that's like an ordered pair, but there's 3 of them, we would write it as 1/2, comma, 2/3, comma, 2. And we always write our ordered triples in alphabetical order unless stated otherwise. Okay, so if it's not going to be in alphabetical order, it will say on the instructions. Okay, so let's look back at that question. 1/2, 2/3, and 2. Actually, let me go ahead and copy this over onto our slide. Okay, so we said that our solution was 1/2, comma, 2/3, comma, 2. Now, if I wanted to check that, if I didn't have 100% faith that I had done it correctly into the calculator, What I can do is replace this A, B, and C and substitute it into my equations. Very similar to what we did with the table in a couple sections ago when we checked our graph with a table. We can essentially do the same thing with 3 variables. I'll substitute all 3 variables and then check. Does it equal what it's supposed to equal? Okay. Now, I know that we did this correctly, so we're not going to do that this time. Okay. But let's go ahead and practice another one with 3 variables. So for our next one, we want to find the solution to the system of equations. And the first step for doing that, because we have 3 variables, we're going to go ahead and use our matrices. Now we can absolutely do this by hand, but it's a very long process. And so I'm going to present you with just a shortcut. If you want to, you can always use your matrix, okay? You can always use your calculator for these. If you want to see how to do this by hand, set up office hours with me and I would be more than happy to go through it with you. But for the purposes of this class, we're going to go ahead and turn this into a matrix. So I'm going to say, okay, my A's are lined up, my B's are lined up, my C's are lined up, and my constants are lined up. Excellent. So I have A, B, C, and equals. My coefficients, I have 1, 4, 6, and then my equals, my constant is 21. 2, -2, 1, and 4. 0, -8, 1, and -1. Now you cannot leave that 0 empty. If you try to leave that blank, you will get an error message if you try to delete it, okay? You can't leave any part of this matrix blank in order to use this. So if we store this in matrix A on the calculator, we are going to want the reduced row echelon form of matrix A. Okay, that's what we just did on the calculator. Let's do it again together. Okay. So if we look at our calculator, what we're going to do is go second matrix, over to edit, hit enter. We have 3 equations. So our answer is going to be 3 by 4. And then what we want to do is type in the values that we just found. So enter, enter, the 3 by 4 is already correct. And then what we want to do is A was 1, enter. 4, 6, 21, enter. Okay, that was our first equation. Our second equation, we have 2, -2, 1, and 4. That was our second equation. Okay, feel free to pause the video if you need a little bit more time, if you're still working on getting to this page. 0, -8, 1, and -1. Okay, so we've got it into the matrix. Next, what we want to do is simplify this matrix. We want to solve the matrix. So, and this is the step that we often forget, we need to leave the matrix. Okay, to do that, we're going to quit. Second, quit. Okay, I'm going to clear the screen here so that we have a fresh screen. And what we want to do is we want to calculate with our matrix. So we're going to go back into the matrix menu. This time, we don't want to edit the matrix. We want to do math with it. So we're going to go to the right arrow for math. And then we're going to go all the way down to B and hit enter for reduced row echelon form. You don't have to know what that means, okay? Just RREF. But what are you taking RREF of? It needs to be, this is like me saying, oh, well, just times 2. You need something to multiply by 2, right? So we need something, we need a matrix to do the row echelon form of. So we're gonna do a second matrix. And again, we put this in matrix A, so we're just gonna use matrix A. Proper notation is to close your parentheses. Probably won't give you an error if you don't, but you should. And then we hit enter. Now this time it's all numbers. 1/2, I know 0.5 is 1/2, so we can leave it in decimal form, or we can turn it into fraction form if we want. We would go math, fraction, enter. Okay, and now we have our solutions. So let's go back to the slide and write those in. Okay, so we have our reduced row echelon form. We knew that our columns are A, B, C, and equals. So this tells me that A equals 1. This tells me that B, because it's in my B column, equals 1/2, and C equals 3. So our solution here, if we write it as A equals B equals C equals, that's this way. If we write it as an ordered triple, which is like an ordered pair, but 3 of them, that's 1, 1/2, 3. Okay, so this is an example of why it's so important to have the difference between set notation, this is a list of items, versus this is a point. Okay, now a point doesn't only have to have 2 parts to it, it's not just X and Y. In this case, it's an ordered triple, meaning it's a 3-dimensional point. Okay, so make sure that you're keeping your notation correct. For these, we're doing points. This represents a location on a plane, but this is a parenthesis notation. Whereas when we're doing a list of items, that's going to be the curly bracket notation. Okay. All right. So let's take a look at one more example here. I want you to try this, and then I'm going to give you the answer. I'm not going to go through the process with you. I'm just going to give you the answer. And what I'd like you to do is if you're not sure how to get the answer, I want you to set up office hours with me, okay? Because at this point, this question is just following the directions that we've done together, okay? And if you have questions, that probably means you have a different calculator, that you're not using the same calculator that I'm using. And so I wanna make sure to go through this one-on-one with you, okay? So go ahead and try this and I'll give you the answer. Okay, so once you do the matrix and you store this as matrix A, and then you do the reduced row echelon form of matrix A, what you should end up with is 100010001 with our answer in that last column as 4, 2, and -3. So that gives us the ordered triple 4, 2, -3. Now I can't just look at those last 3 numbers. I always have to look at the first part of the matrix as well. Because if these 3 columns do not have just a diagonal of 1s, that's going to change the answer, okay? For example, if I had 1004, 0102, then sure, I have that, well, in this case, it's X. X is 4, Y is 2, but here I have that 0 equals 3, which is false. So this would give me no solution, okay? So just like before, we have to make sure we're interpreting our answer completely and not just looking at this last column, okay? This is a what if. Okay, the other option that we could have is we could end up with a true statement. Okay, we could have something like 0 equals 0. If 0 equals 0, then that's true, and that would be infinitely many solutions. Okay, now for the purposes of this class, I do want you to be able to tell me if the answer is not an ordered triple, but as far as being able to identify what type of infinite solution or no solution the matrix is giving you, I just want you to be able to go as far as to tell me that it's not a 1-point solution. Okay? All right, we are going to do more practice together in class. However, the rest of your homework is just to try these 4 problems. You can do it on your calculator, but I encourage you to write down all of your steps, okay? Write on your paper, what are you doing with your calculator? And that way, number 1, it's gonna be more memorable. You'll remember it easier. Okay, and number 2, you're getting practicing doing those steps over and over in your calculator so that it's easier when you come to an assessment or when you come to apply this in a future class or in for example, a standardized test or something, you have that kind of muscle memory of how to solve these without having to do all of the tedium of a 3-variable elimination. Okay, so do this. You can absolutely use your calculator, but I want to see those steps. Okay, it shouldn't just be, oh, the answer is this. If you have questions, feel free to email me. Otherwise, I'll see you in class.